Hello, ladies and gentlemen, Root Beer here, and we're going to be finishing off Part B of the 2006 Fermat paper in this video. So that's the grade 11 multiple choice contest, and we're up to question number 20, the last one in Part B. Okay, let's have a look. A bag contains 8 yellow marbles, 7 red marbles, and 5 black marbles. Without looking in the bag, Igor removes N marbles all at once. If he is to be sure that no matter which choice of N marbles he removes, there are at least 4 marbles of one color and at least 3 marbles of another color left in the bag, what is the maximum possible value of N? Alright, so without looking, he has to be sure no matter which ones he chooses. Okay. So, if I think for the answer, so it's 8 plus 7 plus 5, so there's 20 marbles in the bag. If I think that N could be 16, no matter how I choose 16 marbles, there should always be 4 of one color and 3 of a different color left in the bag. Okay, that's the idea. So if I think the answer is 16, a quick way to show that that's not true is to find a way to purposefully pick 16 out that messes with that forces there to be, not 4 of one color or not 3 of another color. Okay, so initial observations. We need to have at least 4 marbles of one color and at least 3 marbles of another color left in the bag. N has to be at most 13, because we have to have at least 7 marbles left. So that's a nice way to narrow things down. So it could never have been 16. So we need to have 4 plus 3 equals 7 out of 20 left. So now, are there any other observations I can make? I find with questions like this that usually you can put a bound or two, but eventually it comes down to, okay, I've got to do some cases. Is the answer 13? Is the answer 12? Is the answer 11? And if we're stuck doing cases, we should think about it logically. Okay? And when we think about it logically, what I mean by that is don't start in this case at the bottom with 1. Because if you can show 1 works, but then later on you show 3 works, did it really matter that you showed 1 could work? Because we want the maximum value of N. So I would start working from the top down. And it varies from question to question what you would need to do. Start from the top down, start from the bottom up, depending on what's being asked. If we were asked for the minimum value of something, we'd want to start at the lowest possible value that we think might work. Other than that, if we're just looking for, another thing we can do is sort of start in the middle and determine, does that one work? Because then that says, oh, we should then look up here or look down here if we really have no idea where we're going with this. And another thing we can do, it's a multiple choice contest. Let's actually look at the answers they give. Maybe they can rule out some numbers for us. So 6, 7, 8, 9, and 10. Automatically, I know, I guess, N has to be at most 10. So we can actually ignore this observation that I made. N is between 6 and 10. Okay? So one thing we could do is we could say, well, could it be 10? Could it be 9? Could it be 8? That sort of thing. Or we could say, well, could it be 8? If it is, great. We just need to check 9 and 10. If it's not, great. We just need to check 6 or 7 to be the possibilities. Because if 8 doesn't work, 9 and 10 take out even more marbles, so they certainly wouldn't work. That's the sort of thing that we can do. We don't need this observation right here. And could be 6 or 10. All right. So we want to have 4 of one color, 3 of another color. We don't really. It can just be those 2 left. So, in what ways can this be sort of violated? If I'm not left with 4 and 3, what ways can this fail? So I could be left with three, at most three of any color, and that would leave me with 9 of them. And I do start off with 3 of any color, right? I've got 8 yellow, 7 red, and 5 black. So I could just remove it so that I get 3 yellow, 3 red, and 3 black left. So that would certainly mess things up there. And that would be removing n is 11. That's weird. Okay, so no matter which choice of n he removes, and we've got 6, 7, 8, 9, and 10, the maximum possible value of n. I'm a little perplexed. So I could have 4 of one. I can't have 4 of another at that point. So I could have 4 of one and 2 of these others, but that would leave me with 8 marbles left in the bag, so I removed 12. So there's a way to mess this up that removes 12. Or I could have 3, 3, and 3. No, never mind. I'm thinking too small. So what I could do is I could have 8 yellows left. I could have 2 reds and 2, I think it was blacks. Right? That would absolutely mess this up. Because I'd have 4 of one, but I wouldn't have 3 of the other. Yeah. So just, and that would be 12 left. So n would have to be 8. So there's a way to mess things up if n is 8. So that means my answer is either n is 6 or n is 7. Yes. Okay. So that satisfies the 4 left, but not the 3 of another left. Okay. So I was thinking too small earlier. Now, so that's the best way to break this rule. You know, I have 4 of one of them left. I picked one color. And I can keep all of it. And that satisfies the at least 4 of one rule. And the other 2 colors only keep 2. And that fails the at least 3. That forces that rule to fail. Okay. And so the most that I could keep of any one color is 8, and then 2 and 2, so that gives me 12 marbles left in the bag, which means I removed 8. So if n is 8, n can't be 8. So if I remove 8 marbles, there's a way to violate this condition of having 4 left and 3 of another color left. Okay. So that's the best way to violate that section of the rule, is to keep 4 but not have 3 of another color. The other way to violate things is to not have 4 left. But that would mean I need at most 3 of each left. So that's at most 9 marbles left. And so that would be n is 11. And this is what I was confused about, because before when I had this 4 here, I was getting, oh, n should be 12, n should be 11. And that wasn't quite working out there. So I'm glad I realized that I could just have all the yellows left. But 9 marbles left, well, I can do it with 12, so that's when it fails. Well, I can fail with even less, which is 8. But I think since those are the only 2 ways I can violate the rules, n's got to be 7. So if n is 7, we have 13 left. We'll just verify this. So we have 13 marbles left. And so 13 is the sum of all the marbles left. 13 over 3 is greater than 4. So at least one color will have 4 left. At most, that color is yellow. So that color has 8 marbles, leaving 13 minus 8 equals 5. And that's for 2 colors. 5 over 2 is greater than 2. So at least, actually, earlier when I said 13 over 3 is greater than 4, one color will have at least 5 left. But so at least 3 left for another color. And that guarantees the rule. So I know there's a way to fail when it's 8, and I've shown that 7 will work, and those are the 2 key parts. So 7 is our answer, and that would be B, because I think they listed them in increasing order. Yes. All right, so that was an interesting one. That was a very logic-based question, and there was some guessing and checking, which I'm never a big fan of. I like being able to say, do this calculation, add this theorem, there's your answer. Whereas these logic questions, these removing things from the bag questions like this, and how many left, and what's the maximum possible value sort of things, they do pop up from time to time, and you really have to stop and think your way through it. And for a moment there, I was sort of spinning my wheels. I could show that with 9 left in the bag we could fail, or with 8 left in the bag we could fail, but I did not make that connection for a moment that, hey, I can just leave all 8 yellow marbles, 2 reds, and 2 blacks, and that would fail the end condition. So, yeah, that's question 20. Up next are the Part C questions, and considering this one took me a while, I'm thinking Part C might be kind of hard this year. They do sort of lay out all their questions and say, gee, I think this one's hardest. Let's put it here. I think this one's easiest. It'll go to question 1. So in general, the contest does increase in difficulty. So I'm wondering what I'm going to encounter in the next question with question 21. We'll find out together, or perhaps you'll find out ahead of me if you practice that one before watching the next video. But either way, I will see you guys for question 21 next time.